Hello and welcome to this class. For today, we try to proceed from where we stopped in our next class. Our last class, we stopped on the type of set. So in our last class, we discussed about the definition of set and the kind of bracket a set use. Right? We discussed about set notation. So I will drop the link to our last class on set, the introduction in our last class on set, in the description of this video. So check the description of this video before you to watch our first class on set. So let's proceed from where we stopped. In the last class, we stopped on number 4 for the fourth type of set that we have. Let's move to the fifth type of set that we have. Right, the fifth type of set that we have the par set. Alright, we have the par set. What's par set by definition? Given a set A, the par set of A is written as P of A, the par set of A, P of A to power n. Given a set A, the par set of A is written as P to power A, it will be equal to 2 to power n, where n is equal to what? Number of elements in the set, where n, this n here is called number of elements in the set. Alright, even if I'm saying, let's say I'm giving a set B, the par set of B will be what? The same thing. You just change from to B. That's the technique there, right? If I'm giving a set D, just change it to D and put this formula here. So that's like the idea behind par set. Okay, what's now the function of the par set? Put down. It tells the total number of subsets that can be got in a set. So par set tells the total number of subsets that can be got in a set. That's like the idea there. Alright, at this point here, let's take some example to further explain par set. When it comes to par set, let's say I'm given a set, and at the end of the day, let's say I'm given a set P. My par set of P becomes 8. It means that from that par set 8, I can draft out what? 8 subsets. Because I said that par set tells the total number of subsets that can be got in a set. And I explained subset last class for you, and superset. And this subset is, let's say I'm given element A and B. Sorry, set A and B, such that all the elements in B can be found in A. In that case, B becomes what? Subset of A. Now look up please. Let's take example 1 before I explain this concept. Example: write the par set and also list out the subset of the following set below. Write the par set and also list out the subset of the following set below. Number 1 there, let's start with A to be equal to an empty set. Number 2 there, B to be equal to a singleton set. 3 to be equal to let's say there is 1, 2, 4 to be equal to let me use A, B, and C. Right, so let's try to solve this example here. The example says write out the par set of each of them and also list out the subsets simultaneously. So it means that let's start with number 1 here, solution. Listen, I'm writing out the word par set and also what? Listen at the subset. So for my number 1 here, I have that A is equal to what? An empty set. This is an empty set. Right? So let's write the par set of A. So the par set of this A becomes P of A to be equal to 2 to power n. We said n is what? Number of elements in the set. So how many elements here? Nothing. That's 0. So n is equal to 0. This means that the par set of A is equal to what? 2 to power n is what? 0. I have 0 here. From the idea of indices, any number or perhaps any value raised to power 0 is what? Is 1. So it means that here P of A will be equal to just 1. I'm having part of A here to be 1. It means that my subset is just 1. So let's write subset. Because in the question we're told to list out, write out the part set and also list out the subset. Now when it comes to listing out subset, your first priority to start with what? An empty set. So start an empty set. So listing out subsets, start with what? An empty set first. Next up, when you are done with an empty set, check your elements, your set A. What are you seeing here? There's nothing here, so I'm done. So after pressing a subset, you now start to check your given set. When you check it and check, is there any element here? No element there. So that's all. So it means I'm having one part set and one subset. This makes sense. Let's do B to understand it more better. Let's do B. Number 2 there. Number 2 says B is equal to set. This is a singleton set. Why? It contains just one element. Let's get the part of B. So P of B is equal to 2 to the power what? N. In this case here, what's my N? N is equal to what value there? N is equal to, this is just one element. I have one here. So the part of B, that is P of B, is equal to what? 2 to the power. What's N in this case? N is 1. This means that the part of B is equal to any value raised to the power 1 is what? That value. So 2 to the power 1 is what? Is 2. So I'll have 2 at this point here. So for an overview, it means that my part of B is just 2. So it means I'll have 2 subsets. Let's list our subset, please. For the subset, our first priorities was start with what? An empty set. So start an empty set first. Start with what? An empty set. When you are done, check your set B. Your set B. This is my set B. What am I seeing here? I'm seeing 3. Pick out 3. I'll have 3 like this. Aside from 3, is there other element here? No, that's all. So that is like, that's all. So it means I'm having 2 subsets, 2 per set. Makes sense. Hang on. Let's do 4. Let's do 3 and 4 to understand it more better. Let's do 3. For 3, I have C to be equal to 1 and 2. Let's get a part of B of C per se. So P of C is equal to what? 2 to the power N. In this case, what's my N? N is 2 elements here. That's 2. So the part of P of C, let's say, is 2 to the power 2. Final answer then becomes P of C is equal to 4. So I'm having what? 4 per set. It means that my subset is 4. Let's get subset here. To get subset is quite simple. First start with what? An empty set. So it means that my subset here is that start an empty set first. So an empty set is this, an empty set first. When you are done with an empty set, check your given set, your set C. I'm having 1 and 2. So to start with 1, I'll have 1. Start with 1. When you are done with 1, next element there is 2. Pick out 2. When you are done with 2, see, your first time to start an empty set. When you are done, pick them in ones. This is 1 here, this is 2 here. After picking them in ones, pick them in 2s, right? So that becomes 1, 2 now. Next time becomes 1, 2, right? So that's all. Pick them in 2s. Your first task, start an empty set. When you are done an empty set, pick the element in ones. Pick 1. I have 2 elements here, so pick this one as 1, as 2. When you are done picking them in ones, pick them in 2s. 1, 2. This is here. Don't say after picking this 1, 2. Don't say 2, 1 again. 1, 2, and 2, 1 the same thing, right? So just move forward. So start with an empty set. Pick them in ones. 1, 2. After picking them in ones, pick them in 2s. 1, 2. I have it here. So it means that I'm having what? 4 per set and what? 4 subsets 1, 2, 3, 4. This is how to find the subset of an element there. Let's do number 4 and understand this idea. Let's do 4. Yes, this 4 here. Let's get the pass set of 4. 4 says D is equal to let's start A, B, and C in this case here. Alright, okay. Alright, for this one here, let's get P of D. P of D is equal to 2 power n. What's n in this case? 1, 2, 3. N is 3. It means that pass set of D is equal to 2 to the power 3. 2 to the power 3 means 3. 2 in 3 places. 2 times 2 is 4. 4 times 2 is 8. So I'm having 8 pass set of D. So the pass set of D is equal to 8. So let's list out subset, please. Let's list out subset. We said when it comes to listing out subsets, your first priority is what? Start with an empty set. So have an empty set first. When you are done, pick the element in ones. So I have element in ones. I have A first. Next up, I have B. Pick them in ones. I have C. When you are done, pick them in ones. Pick them in twos. So I have A, B. Next part, I have A, B. Look up A, B. Next up, A, C. I'll have A, C. When you are done with A, B, next up, move on to what? A, C. When you are done with A, C, move on to what? B, C. I'll have B, C. Right? So let's see. This is 1, 2, 3, 4, 5, 6, 7. So the main one. So it means that start with an empty set. When you are done, pick them in ones. 1, 2, 3. When you are done, pick them in ones. Pick them in twos. Now, after starting with an empty set, next up, pick them in ones. I have A, I have B, I have C. When you are done picking them in ones, pick them in twos. Right? Pick them in twos. So I have A, B, A, B, A, C, and what? BC here. When you are done, pick them in twos. What's next? Pick them in threes. So have pick them in threes. I have A, B, and C. So this is how to write out the pass. So this is how to write out the pass set and also list out the subset of a given set. That's like the number 4. Let's number 5, please. Number 5. Let's move to the next set called cardinality of a set. What's the idea behind cardinality of a set? Given a set A, the cardinality of set A is written as the cardinality of A is written as n of A. The cardinality of A is written as n of A. It tells the total number of elements in a set. That's all. When it comes to cardinality, the cardinality tells you the total number of elements in a set. So, given a set A, the cardinality of A is written as what? N of A, as in this case. So it tells the total number of elements in a set. Example, let's say I have a set A to be equal to 6, 7, 9, 10, 11, as in this case here. Find the cardinality of A. That is n of A here is equal to what? Count the number of elements. 1, 2, 3, 4, 5. So the cardinality of A here is equal to 5. So cardinality tells you the total number of elements that can be got from a set. That's like the definition behind cardinality of a set. Alright, from here, let's use this idea to do something. Okay, from here, let's go to the next Okay, let's take up some example here. Let's take up some sample problem. Sample problem. Let me give you. I'll give you a set in form of. Okay, I'll give you a set in form of set builders. You give me the cardinality. Look up. I'll give you a set in form of set builder. You give me the cardinality. Let's have having a set P to be equal to X, such that X is the number of bone in human body. So let's try to solve this together. So given a set P such that X is equal to number of bone in human body. What's the cardinality of P? So N of P is equal to how many bone does human being have? That's right there. If you don't know it, you can't do this one. So let's get the cardinality of P. So N of P is equal to what? What's the number of bone in human body? That should be around 206. So have 206. So if you don't know number of bone, so you can't do this one, right? So this one is what in form of set builders. So this is the cardinality here, right? So let's take one more example there. One more example. Give me a set Q to be equal to X, such that X is the number of local government in Nigeria. So what is the cardinality of Q? N of Q is equal to what? How many number of local governments in Nigeria? That is equal to what? 774. That's the total number of local governments in Nigeria. 774. There. Alright, down to this seventh type of set called complement of a set. Complement of a set. Alright, let's discuss complement of a set. Definition. Given a set A, the complement of A is written as A to power C, or perhaps we use A prime. The complement of A is written as A to power C, or better still, A prime. So if I'm saying A to power C, it means that complement of A. If I'm saying A prime, it means what? Complement of A. What's not the meaning behind this? It gives the total number of elements in the universal set that is not in set A. I'm saying that it gives the total number of elements in the universal set that is not in set A. I said, given a set A, the complement of A is written as this, comma. It gives the total number of elements in the universal set not in set A. That's like the definition behind complement of a set. Let's say example there. An example is that, let's say I have example. If I have a universal set to be equal to, perhaps we haven't defined universal set. Let's do number 8 first before we move to before I show you an example on this. Let's explain something. The eighth example. Universal set. What is a universal set? A universal set is a set of all possible elements. That's the definition. A universal set is a set of all possible elements. I should like give you this one before this, but mind you, it's still okay. So you can actually swap it. You can make this one come here before this one, anyhow it is. But a universal set is a set of all possible elements, right? So this. So the symbol for representing a universal set is simply U, something like this, right? That's a symbol for representing a universal set. So let's take an example here. So example, let's say I'm given a universal set U to be, let's say 1, 2, 4, 6, and 10 in this case, and I'm given an element and a set A to be equal to 2, 6, and 5. Perhaps let's take 8 in this case. Now find, the question says find A prime. The question says find A prime. You know A prime, you see what the complement. You say is either A to power C or A prime. You see what the complement. So to get A prime, so it means that A prime is equal to, A prime means give me the element in the universal set, not in set A. Element in universal set here, not in set A. Observe that the element in universal set that are not in set A, that's the meaning of A prime. So give me the element in the universal set, not in set A. One is, so let's check up. One is universal set, but not in set A. So I'll write out 1. What again? 2. I'll take it out. 2 is here, 2 is here. I don't need it. 4. 4 is here, 4 is not here. I'll put out 4. Next up, 6 is here, 6 is here. Take it out. 10 is here, 10 is not here. I'll write out 10 here. So this is like the idea behind A prime. So A prime simply means element, or perhaps A prime means that give me the element in universal set, not in what? In set A. This is like the idea behind complement of a set. Let's discuss the ninth type of set called relative complement, or you call it relative complement, or you call it different of a set. Different of set. Relative complement, or you call it different of a set. Definition: given a set A and B, their relative complement or their different is written as A minus B or B minus A. So I'm saying that given a set A and B, their relative complement is written as A minus B or B minus A, or perhaps their different of the set is written as A minus B or B minus A. So that's, by the way, for that one, comma, where A minus B is the element, where A minus B gives the element in A, not in B. So A minus B gives the element in A, not in B. Why this one? Simply means B minus A means B minus A gives the element in B, not in A. So I'm saying that relative complement of a set is when a set is having A minus B, B minus A. So when it's in A minus B is the case to it, B minus A is the case to it. When it's A minus B, what does it mean? It means that it gives element in A, not in B. B minus A gives element in B, not in A. Example, to understand this concept. Example, let's say I have a set A to be equal to 2, 4, 6, 8, 10 in this case, and I have a set B to be equal to let's say 1, 2, 3, 4, 5, and 6 in this case. Now the question says find A minus B. The question says find A minus B. The second question says find B minus A. Let's get A minus B and B minus A in this case here. So this means that my A minus B, so from here it means that A minus B simply means A minus B. Now I said A minus B means what? Element, it gives the element in A, not in B. Check here. What are the elements in A that are not in B? 2 is in A, 2 is in B. No.
4 is in A, 4 is in B, no. 6 is in A, 6 is in B, no. 8 and 10 are elements in A, but not in B. So I'm writing them out. 8 and 10 are the two elements in A, not in B. Now let's get B minus A. For B minus A, the same tax there. All the elements in B, not in A. So B minus A gives elements in B, not in A. Check here. What are the elements here that are not here? That's 1, 3, 5. 1, 3, 5. So 1, 3, 5 are simply the elements in B, not in A. That's like the idea behind relative complement of a set. Let's dive into one other concept called basic set operation. Basic set operation. Basic set operation. Number one, union of set. Number one, union of set. Let's define union of set. Given a set A and B, their union is written as A union B. Observe my union. My union is not having tail. This is wrong. A union is a what? A parabolic curve this way. So I'm having a parabolic curve like this. This is a union. So it means that A union B is like the mathematical expression for union of a set. So I'm saying that give me a set A and B, their union is written as what? A union B. It gives the element in A and B without repetition. It gives the combination per se. It gives the combination of elements in A and B without repetition. So let's say I'm having element A and element B. I'm having element A to be equal to, let's say, 2, 8, 10, 12, and 16. Next up, I'm having element B to be equal to 8, 2, 15, it's 16 here, 15, 30, 30. All right, let's use this example here. I'm giving elements A and B. So the question says, find A union B. Find A union B. How do you go about this? Let's try to get A union B. So A union B simply means I'm combining both the elements in A and B without repetition. That's the idea. I'm combining elements in A and B without what? The repetition. Look up, please. Let's find solution. Let's get A union B. A union B simply means what? Combining elements in A and B without repetition. Start with 2. I have 2. Next up, what next? Is that 3 there? Okay, 2. What's next there? 8 is the next value there. 8. Observe that 8 and 8 is here. I'm not repeating it. Pick it once. So 8. After it, I'll have the 10. I'll have 10. Next up, 12. After 12 there, I'll have 15. 15. Next up, I'll have 15, 16. So I'm combining the two of them, 16 and 30 and 30. So this is like the question, the answer to the question here. Find A union B. So you combine the two of them. Everything, you're writing everything outside there. But start with the smallest value, which is 2. Next up, 8. Next up, 10, 12, 15, 16, and 30. But observe that 8 appear 2 times. 2 appear 2 times. You don't repeat it. Just pick out 1 and you are there. That's like the way of approaching the union of a set. Let's discuss what we called the second basic set operation called intersection of set. Intersection of set. What is the meaning of intersection of set? Definition. Given a set A and B, their intersection is written as A intersection B. It gives the it gives the elements that are common in both set A and B. Yes, A intersection B simply means it gives the element, it gives the common element per se, common element in A and B without repetition, but per se. Yeah. So when it comes to intersection of a set, here's what you need to note. I'm taking the common element between the two. Let's say I'm using this example. So let's say example, given a set A and B, which are this. So the question now says find A union, intersection B. To find A intersection B is quite a simple process. We said is that our first task is that I'm combined for intersection. I'm taking their common element. Check here and here, which is common. 2 is common, 2 is common, 8 is common, 8 is common. That's all. So I'm having 2 and 8. 2 and 8 as my common element in both set A and B. So when it comes to intersection of a set, we're actually looking for the common element in set A and B. That's all, right? That's like the idea behind all this stuff. Let's take a past question, one JAMB past question, and let's call it a day. All right, here's the question here. The question says, find T intersection N. So I'm given T to be this and N to be this. So note that this LMA set T is given in form of what? Set builders. So they are given in form of set builders, right? So your first task to solve this one is that, can you write them in terms of by listing? So let's write some in terms of by listing. So solution to this. Solution, my first task is that I'm given a set T to be equal to even number from 1 to 12. And that becomes 2, 4, 6, 8, 10, and 12. I'm done with this. I'm writing that one. This one is in form of set builder to by listing. Next up, I'm having set N. Take set N to by listing. Common factor of 6, 8, and 12. That's 2. So I have 2 as my common factor for the 6, 8, and 12. At this point here, the question says find T intersection N. So it means that T intersection N is equal to, what is intersection? We just said intersection is simply the common element between set A and B. I'm having set T and N. What is common between set T and N? That is what? 2. So my answer here is what? 2. So that's option D is my answer there. So your task here now is to go home and try to solve other past questions, right? So here's my advice. Great teacher do not make great student. Great students make themselves great from the instructions of great teachers. Here's my advice. Go home, treat this topic, take past questions, online questions, textbooks, and solve them. So all right, that's like that. Yeah. All right, see you next class. Bye.